we need to let you in on a couple of notations. Okay, coast is clear. The notation for the derivative looks just like that for a function, with the addition of a little slashy dot thing after the f. That little slashy dot thing is called a prime, and the expression is read f prime of x. An alternative notation is y prime, because f of x and y are interchangeable. And finally, another way to think of it is with the notation dy over dx, meaning the change in the y's divided by the change in the x's, which is what a slope is.
Okay, we're about to give you the definition of the derivative. But first you need to follow me on this last point. This is the key to understanding what the heck a derivative really is. Remember, we said that the derivative is the slope of the tangent line at a specific point. And we remember that the slope of the line is simply the change in y values over the change in x values. Now, in order to use this slope formula, we need 2 points. For the purposes of the derivative, those 2 points are x, f of x, and x plus h, f of the quantity x plus h. Where did we get those points? Well, x, f of x, is just the starting point xy, but we are representing y with f of x. The second point is represented by x plus h, f of the quantity x plus h, where h is simply the change in x. Now we have 2 points.
Now that we have our 2 points, we can find the slope of the line between them with the slope formula. You remember the slope formula, don't you? The slope is just the change in y's over the change in x's, or, as we see here, y2 minus y1 over x2 minus x1. Now, let's take our 2 points and plug them into this formula. Our y points are f of x plus h and f of x. Our x points are x plus h and x. Now, if we put those in the formula, we get f of x plus h minus f of x over x plus h minus x. We can simplify the denominator because the x's subtract each other out. So, we are left with f of x plus h minus f of x all over h. Remember, h represents a change in x values.
Look here. If we take the new formula we just got and take the limit of that as h approaches 0, then we have the definition of the derivative. It reads, the derivative of a function f, or f prime of x, equals the limit of f of x plus h minus f of x, all divided by h as h approaches 0. So, we see that the derivative is just a slope. But if we look closer, we see that the numerator is the change in values of the function during an interval h, and the denominator is just the amount of the interval h. So, the derivative is not just the limit of a slope, it is also the limit of the change in values of f of x over the change in x, or the instantaneous rate of change.
Okay, so you're looking at the definition of the derivative and thinking to yourself, what the heck is this thing? What is this dang h? Why is this so ugly looking? Well, it's really not that bad. All it is a slight variation on the good old slope formula you used as a kid, rise over run, change in y's over change in x's. So hang in there, you'll get it eventually.
Okay, here we go. Suppose we're given the function f of x equals 4x squared minus 8x plus 3, and we're asked to find the f prime of 2. So let's use the definition of the derivative to find it.
To solve this problem, the first thing we do is sub our x in the derivative definition. In our problem, x equals 2 because we're looking for f prime of 2. So we sub in 2 for x in the derivative definition, and we get f prime of 2 equals the limit of f of 2 plus h minus f of 2 all over h as h approaches 0. Now to complete this substitution, we need to find f of 2 plus h and f of 2. How? Easy. To get f of 2, we'll substitute 2 into the given function, 4x squared minus 8x plus 3, just as we would if we were given any x value and we're trying to find the corresponding y value. So substituting 2 for x, you get 4 times 2 squared minus 8 times 2 plus 3, which equals 3. So we've got f of 2. It's 3. In other words, we just found that the x and y coordinates for this point are 2, 3. So f of 2 will get put into the derivative formula as 3.
Now to complete the derivative formula, we need f of the quantity 2 plus h. How do we get it? Heck, we just slap it back into the original function. Every place we see x, we just plug in the quantity 2 plus h. By substituting 2 plus h for x, we get 4 times 2 plus h squared minus 8 times 2 plus h plus 3. It looks nasty now, but if we multiply it out and simplify, we are left with 4h squared plus 8h plus 3.
Now, all we have to do to get the derivative is substitute our new values for f of 2 and f of 2 plus h back into the derivative formula. So, we put in 4h squared plus 8h plus 3 in for f of 2 plus h, and 3 in for f of 2. We can't substitute 0 for h yet because we'd get 0 in the denominator. Remember, when doing limits, if you can't substitute, then try simplifying and factoring. In the numerator, after subtracting out the 3's, we can factor an h out and cancel the h's in both the numerator and the denominator. Now we can substitute 0 for h. That gives us f prime of 2 equals 8. So, after all that, the derivative of f of 2 is equal to 8. So, for the point 2, 3, which is the point on the function we just found the derivative for, we know that the slope is 8, because the derivative is the slope at that point on the curve.
We just found the derivative at a particular point on the function using the definition. Repeating that mess of computations for other x values would be tedious at best. So let's find a general formula for the derivative of our function. That way, we can find the derivative for any value of x on this function a lot quicker.
Now let's find that general formula for the derivative. Back to the derivative definition, which you see here. Now instead of evaluating for a specific point, we will sub in the full generality. We know what f of x is because we were given it originally, and f of x plus h is just found by substituting the quantity x plus h in for x in the original function. So, f of x plus h equals 4 times x plus h, quantity squared, minus 8 times x plus h plus 3. When we multiply this out and combine terms, we get f of x plus h equals 4x squared plus 8xh plus 4h squared minus 8x minus 8h plus 3. Whew, easy for me to say. If we stick these values for f of x and f of x plus h back into the derivative definition and simplify, we will get the general formula for the derivative at any point on this function.
Here we go. Subbing in our f of x and then our f of x plus h, here's what we get. Now we've got to do all the math. After simplifying, we get 8xh plus 4h squared minus 8h all over h. Again, we can't determine this limit by straight substitution because we would get a 0 in the denominator. So we factor out an h in the numerator and then cancel out the h in both the numerator and denominator. We're left with the limit as h approaches 0 of 8x plus 4h minus 8.
Now we're back in the limit world. Substitute 0 into the expression for h, because based on the original derivative formula, h is always approaching 0. This gives us 8x minus 8.
So, at any value for x, the general formula for the derivative of this particular function is 8x minus 8. To find the derivative at any point, just substitute that value for x into this formula. For example, at the value x equals 3, the derivative would be 8 times 3 minus 8, which equals 16. So, the slope of the tangent line at x equals 3 of the function 4x squared minus 8x plus 3 is 16.
Okay, let's go back over this derivative stuff, starting with the definition of the derivative. The definition of the derivative is just a big formula that looks like this. The derivative of a...
To watch more free educational videos, visit our website, studioforlearning.tv. Stretch your brain online.